Hello, this is Team 167. Our project dived deep into creating price prediction model in stock and crypto market using regression model. We divided the presentation into four parts. To start off, our project ideas is inspired by a newly uprising career field in finance, quantitative analysts, quants for short. Quants are highly skilled mathematicians and data scientists who use complex models and algorithms to analyze financial markets and make investment decisions. And one of the most exciting applications of it is in the development of predictive models for stock prices. Our team has been working on developing a model that uses long short-term memory LSTM neural networks to predict stock prices. For creating the base model, we use closing price and volume of the past few days to predict the price of stock in the future. So as we continue to refine our predictive model, we found many meaningful outcomes, different characteristics of two markets, and unexpected failure. We will discuss them all today. Our initial model failed miserably. To explain the detail, historic stock data are downloaded using Y Finance, and the firm's yearly income statement was downloaded from Yahoo Finance website as a CSV file. We chose multivariable regression model to predict price of Meta stock for initial testing. The correlations matrix shows no significant result as many features in the income statement were highly dependent to each other. As the regression model's R2 score shows negative 15.52%, it was better to roll dice to predict the market. On the other hand, tree regression showed perfect fit, but we realized we were cheating by feeding actual prices into training. We needed to upgrade our game. We spent many hours on choosing new regression model to use in the project.
And finally, let's talk about our model, which is a bidirectional multi-layer multivariable LSTM neural network, where we had 80% set for training, 10% for validation, and last 10% for predictions. You can see over here how close we are to actual stock prices. Then we got our best results for mean square error in crypto space on XRP, which is 0.0001, and for R squared it was Bitcoin, where we got 0.597. It is very bad. However, let's talk about our stock market. We're on Meta. We managed to get our R squared up to 0.8876, and this could be probably explained by the market overall growth over the time. So here we can look at our graphs and other models we used. It was XRP USD, where we got a bit different results for our R squared as well as mean squared error. Here's Bitcoin, and here is Meta predictions, where we managed to get our R squared so high. This could be possible due to two reasons. The one is a stock market, as I said, and the second one is that we use closing price, volume, and liquidity as features, which is just great because adding useful features actually helps us to predict. And how did we get these results? Well, we used long short-term memory model. As I said, it is complicated neural network, which I'm not going to explain. However, we divided our data and allowed our machine learning algorithm to validate it, train on it, and actually test it. We used time windows of amount of time we use in order to predict one day and how many days we necessarily need to predict. Then we used our multi-everything because we had several features, several layers, and it added actual accuracy as well as complexity to the model. And using additional features actually helps us to get more accuracy when used properly. Bidirectional LSTM means that we used data from both sides, which is past and future, and flexibility is we can easily edit and add new features to our model.
I would like to show you more details of the model's performance in stock market, especially for the Meta stock. I created 4 different versions of the model where each of the model have different kinds of features. As the LSTM1 increases to LSTM4, more features are added into the model. However, for LSTM4, I only added federal interest rate to the base model, which is LSTM1. And as you can see, the R2 score increases. However, if we only add the federal interest rate, the R2 score underperforms than the base model. This is because all the other features are dependent by the federal interest rate. And as you can see in the visualization that the R2 score increases as more features are added in, however, drops significantly when we only add federal interest rate. So what can you do in the real world? So we could get the return of investing $1 into Meta stock using this model and compare that to investing $1 into meta stock and doing nothing. These are the assumptions. On the left, we can see that lower the meta stock goes, the higher the return is, and it performs better during a recession or drop of the stock price. The model predicts stock price lower than the actual price, and we can see that during the overall drop of the meta stock, the model performs better and give us the higher return than investing solely on meta. And before we end the presentation, I would like to say a couple of things. Since we use Y-Finance to download data, the input data updates every day. The R2 score, because of that, fluctuates every day, less or equal to 1%. And Fed interest rate must be updated every month. The LSTM model only works with meta stock data. This is an interesting find, however, we weren't able to find out why it was happening. Thank you for listening to us. Is there any questions?